Welcome in the session of this afternoon. I'm Danilo Demarchi from Politecnico di Torino, and I'm here also representing the COREP, that is the Consorzio for la Ricerca e Educazione Permanente, that is responsible inside the Eurotraining project for the website and some dissemination activities, and this is one of them. So we are here thanks to this project, Eurotraining, in which we have to disseminate, to organize courses, to disseminate courses themselves done around Europe about micro-nano electronics, nanotechnologies. And today, I guess that you understood from the previous presentations, we are talking of Internet of Things. My duty today is to introduce you what you will see in the most of the next sections, in which we will go a little bit deeply inside Internet of Things applied to robotics and biomedical applications. Well, Internet of Things, now we talk a little bit of money. Here are dollars, we are in the Eurozone, but we are interested in dollars too, I guess. And you see that the business and the market of Internet of Things is of great interest. This is why companies, European community itself, and of course a lot of research are working, or research centers are working in the Internet of Things topic. You see here from these first numbers that this report was prepared by this organization, YOLI Development, and in 2014, in June, and they expected for 2014 a business of about $9.5 billion. But the interesting thing is that for the 2024, so in 10 years, they expect to mostly have more than to five more, to increase more, five times more, okay, the business in Internet of Things. In this report, they found mostly three sectors in industry that can be touched and can be, of course, interested thanks to the development in Internet of Things, that are, of course, electronic industry, production of devices, communication and cloud. So the fact that these devices must communicate each other, must share the information, and in a cloud way. Now, cloud fashion now is one of nice and interesting possibilities and technical solutions we have. And we will see, last but not least at all, services. Service companies in which these data are valorized, because we don't have to simply to send data around. We must use them. And this is one of the keys we will see exactly in this study, in which you see that in the first years we have blue related to hardware. So they think, and they, of course, have numbers, have studies that tell us that in the first years, of course, the market will be of interest of people who are developing devices, so electronics, hardware, because hardware needed for the setup of the infrastructures. But after, in 2019-20, okay, the importance of data will increase. So the point is that I took this phrase from this report, that the data processing will be available more and more and at a low cost. So where is the business? The more data means a higher value of the data, because the content of the data becomes of great interest. And so all this, it is good because of infrastructural investment, but service companies will be the big winners in this field. And this is why I had the idea to title this workshop in joint work, a joint activity between university and companies, SMEs, because exactly SMEs can be the ones who can be engaged in this work on doing services. Of course, electronics, silicon components, we cannot expect a small company to enter. In this case, we have the big guys. We have ST Microelectronics, so chip producers, Infineon, and so on. But after that this infrastructure is done, it is a good time for people for setting up new services, new idea. And in this case, you can do it thanks to the fact that you are small. And so you are a dynamic company that can put in the market innovative ideas. And of course, I'm a researcher, so this is also a great opportunity for the research, for university to cooperate together to set up new interesting solutions and values for the society. And you see here are mentioned in this plot some other interesting messages. Because we are talking of a great, very high impact in the future from printed electronics, from flexible electronics too, because of course you want to insert and put electronics everywhere. It means that you don't have to have limits in terms of flexibility, in terms also, in this case, printed electronics, you must produce very low cost, very effective devices with very simple technologies. They say probably as now you have 3D, you can have at home something that can print out your circuit and you use it and you do it on your desk, okay? This is one of the goals. And after, you see the importance of polymers, so polytronics, and the integration, the smart systems, so the work that you must do to put the things together and let them work in an efficient way. So, of course, you already had from the previous talks, from the next talks, you will have confirmation of it, but which are the needs from a technical point of view for designers, and from the other side, companies who want to invest and set up new services and new devices, new products. Low power, okay, of course, everything must be low power now, and the wireless interconnection to the cloud. These are the two most important things that one device in Internet of Things must have. And the device will contain sensors, will contain the electronics for dealing the messages that I will receive from the sensors, but also from actuating if I want to actuate something, so double way. And some small elaboration, so you don't have to use too much complex algorithm or data elaboration because you want to be low power. So you do the minimum you need on your node, and after you send out your data. And the smart packaging is another very important topic, because we are talking of putting everywhere, so also in maybe more or less harsh environments, different environments at all. So the packaging, it is also another very important point when we start talking of Internet of Things. And in the next presentations, you will see one approach that here in Torino, it's a mixed work between Politecnico di Torino and the Italian Institute of Technology, in which we are applying this concept, this approach that we name Bioinspired Approach in electronics. We start from, and my colleagues later will go in details of it, but I just give you the first scope, the first sketch on it. We've started from the idea that the brain communicates with the body with spikes, and how the spikes are produced, how the spikes are organized, they tell you something. The information is contained in the number of spikes, in the distance and time of the spikes, and all this, it is very interesting from the power point of view, because it's very efficient from power point of view, because you consume as less as possible if you communicate with a small spike, so you put out a small energy for saying something. And they are, of course, based on event. They happen when it's needed. When something happens, I activate something. If nothing happens, I don't activate anything, so I don't consume. And of course, they are asynchronous. They arrive when is needed. And so we want to use this approach for doing sensing, for doing control, for using this way for communicating in wireless with data. If you use impulse radio ultra-wideband, so a wireless communication based on pulses, you take the pulses and you transmit them. And so the approach is, again, very low cost in terms of power. We don't need analog to digital converters at all. We take the spike and we send it out. And also now people around the world, of course we are not alone working on this, are working in setting up processors, microprocessors, units that can elaborate this with pulses, with this new approach. And so we can summarize. The concept is driven by events, asynchronous, and based on pulses. Okay? And my colleagues will go in details. So the efforts and the skills that we have to apply for setting up these devices and from also systems start from RF, then electronics, mixed, analog, and also, of course, digital, and power electronics. Also, new way, new possibilities. Previously was presented a talk. A talk was about energy harvesting, energy production. Okay, and we are applying this on what we can consider a platform that is good for development of these new applications. And the idea is to apply this concept to ICAB. You know, I guess, very well, this robot from Italian Institute of Technology. And the idea is to apply this event-driven communication, this address event representation, so the fact that I give an address to the events that I'm receiving, that in this, from these addresses, from these events, I receive information I want. And in this case, in particular, we are working on tactile sensing. So we set up some custom chips, and now you see also here the boards that are using. Now we did a demo for this technology, but of course, in principle, is to arrive to a unique chip for detecting the tactile sensor and to give, more than detecting, to give the tactile sensing to ICAB, to the robot. And it is possible to apply the same concept, so we move to biosignals, to read the biosignal in a different way. Means I do not sample the signal. I just take the signal when again is needed, when it passes a threshold. So when my signal starts telling me something. Of course, this approach is not applicable to everything, because there are applications in which you need clearly your signal, the full signal, very well sampled, but there are a lot of applications. And the one can be, and we started also doing some work on it with some colleagues in Italian Institute of Technology, to recognize the movement of the ends through an electromyographic signal readout and sending this information about the movement you are doing to a robot or to an exoskeleton or something. And I show you here one of the examples that clearly show you the goal of the work. But you see also in this slide an interesting thing in which we are talking of usually Wi-Fi low power 100 milliwatts. Which if you use a very low power Bluetooth, you reach 1 milliwatts. The goal with ultra wideband is to go down to 30 microwatts. So to decrease abruptly the quantity of power that you have to consume to transmit. And this is the concept, and we did an example setting up a force measurement of the force that you are applying to your arm, and so to your muscles, of course. And in this case, with the threshold, put in one threshold, we were able to send out an information related to how much and how much was the quantity of the force applied to my muscles in my arm. And okay, in this picture, it is our final goal. So to develop a unique chip in which you have your electrodes, your electronics, and your wireless. And you will see I touch this concept for the first time, but this concept, it will be applicable also in other situations that I show you soon. And this is very quickly, but my colleagues will go in details on the results we obtained. And this is what I was mentioning you. The other approach, putting all together sensor, electronics, and wireless transmission, it is also a concept that we named micro for nano, so micro and nano probing. So the fact that we want to apply similar concept that I just mentioned you to the sensors, so to have the probing. If I want to build an efficient sensor, one of the most interesting possibilities is to use electrodes. And so in this case, I need probes. I need something that has to contact what I want to measure. So I want to measure a molecule, biomolecule. I want to contact a piezo-resistive material that is changing resistance because of the pressure. So different possibilities using electrodes. But one of the best problems I have in sensors is that the sensor is far from the electronics, and so I have a lot of noise. In this case, what we are doing, and Alberto later will specifically tell you about it, we are integrating electronics, readout, sensing, and the communication by wireless. Not done yet, but the first two steps are already done. So I have electrodes contacting micro or nano things, because it depends if I need to contact at micro level or nano level, and down there I have my electronics, the readout. And this is the approach. In this case, just quickly show you, and you will have later more details on it. You see here, you have your silicon chip. On the top of the silicon chip, you have electrodes. In this test, we put different distances between the electrodes to check different, of course, behaviors. And down here, you see the electronics. So you have the readout chip. You have, in this case, a dielectrophoresis circuit useful for collecting molecules in the middle of the electrodes. It's a technique very efficient. Also to integrate micro and nano, because if you are able to create, and we are working to create nano gaps between these two electrodes, you are able to create nano electrodes that can contact nano molecules, nano things in general. And connecting to the start, we apply the concept of event-driven, asynchronous, blah, blah, blah. The fact that the exit of our sensors, the transduction is done exiting with a periodic signal with a square wave, in which in this case we are talking of a piezo-resistive material. The period or the frequency of my signal, it is proportional to the resistance that I read from my sensor. And for me, each, for example, rising edge is a pulse. So I transform my periodic signal, my square wave, in pulses. So each rising edge, for example, can be a one pulse. And I transmit these pulses, okay? And I can add a very important thing that colleagues and friends from measurement field, they teach me that measurement in frequency are very precise and are one of the most interesting way of doing measurement. Okay, and I moved from robotics to bio because again the concept is similar, but in this case we did also test building biosensors. In this case we put in the middle of the electrodes I mentioned some micro wires, nano wires, depending on the distance between the electrodes. In this case we use zinc oxide nanowires for detecting a protein, a BSA protein, and so you see here, and in the next talks the colleagues will go a little bit in details of it, and you see here that I have a proportional value in the capacitance due to the change in time of the concentration of BSA, so a working device. I thank you so much for your attention, and if you have questions, I'm here. And now let's go further to the other talks. Thank you.